Hello friends, this is G Solutions where we find solutions for your needs. Okay, so today I will explain to you the three types of power. Three types of power. Okay, so this can only happen in an alternating current supply because the behavior of the capacitor and the inductor plays a significant effect to the circuit, and therefore, we produce these three types of power. So, by the way, if you will notice, some of our circuit are drawn with a rectangular box. Okay, and this rectangular box is named as Z, or the impedance. Why is it that we are using this one? Because we know that the impedance, or the Z, is equal to the resistance plus Jx. So there are two terms involved in your impedance. The first one is the R, which is the real, or the real part, and this one is the imaginary part. So we know this already, imaginary. So the real part is actually, this is the resistor. Okay, so this is the resistor. And the imaginary part, which is Jx, this will be the, what we call the inductive or capacitive reactance. It can be inductive or capacitive. Okay, reactance, or this is the reactance. It is represented by X. Okay, so it will be inductive if it is more on the inductance. It will be capacitive reactance if it is more on the capacitor. So this sign here, I will put here a negative sign because we can determine if X is inductive or capacitive. If our X is positive, that will be more inductive, or that is an inductive reactance. But if it is a negative sign, it is a capacitive reactance. So that's why we are writing it here in our schematic drawing as a rectangular box. For we don't know really the resistor, or the capacitor, or the inductor is involved in our Z, because sometimes our resistor can be zero and it is a pure, we say it as a pure reactance. It can be pure inductive or pure capacitive, or sometimes our reactance part is also zero and that is a pure resistive. So it is represented here as Z, and therefore if you introduce in this element Z a power source, which is an alternating current power source, well, I can designate this as my polarity. Okay, and from that my current comes out. So if I'll have it introduce it here, if a voltage is impressed in this element, you will be having three types of power. So what are those power? These are the power that is produced by your resistor, and the power that is produced by your in reactance, and also the total power, which is Z. So the first type of power is what we call the power that is produced by Z. We call this as apparent power. Apparent power. Okay, we are using here a notation letter of S. Okay, that is for the apparent power, and the unit that we are using here is in volt ampere or kilovolt ampere. Okay, this is the power for Z. And the second one, these are the power produced by your resistor, and we call this as real power. The real power. Okay, and we also use the notation letter P. Okay, and the units that we are using here is watts or kilowatts. Okay, so that's it. And the last one, the power that is produced by our reactants, and we call this as reactive power. Okay, reactive power. Okay, and the symbol or the symbol letter that we use is Q, and we are using a unit of B, a volt ampere reactive, or K bar, kilovolt ampere reactive. So the one that you are paying in your utility company, in your home, is based more on this kind of power, the real power. But if you have an industry in which you have a lot of inductive devices there, like motors. You have a lot of motors. You have an air conditioning system. You have an electric water pump, and a lot of other electric motors are there. So probably you will be paying for your apparent power. This one, apparent power. Okay, so it has a different kilowatt hour, or I mean a metering system that is used in the industry and in your home or residential or in the commercial. And also in the industry, they are much more concerned on the power factor that you have. So that's why we are introducing in this system what we call the power factor correction. So you know that these three types of power can be represented in a right triangle. Okay, so I am drawing here a right triangle, and your real power is this side, and the one that is vertical here is your reactive power, which is Q. Now, since this is a right triangle, by Pythagorean theorem, you can find for the hypotenuse, and this hypotenuse is our apparent power. So therefore, if you have all of these sides and you have a value for these sides, you can get the angle here. This angle here is very crucial because this is your theta, and we can adjust the reactive power here by also adjusting the angle here. So this is what we call the power factor correction. And our power factor, okay, our power factor is based on the theta. So the cosine of this theta is your power factor. Therefore, to get the angle, you get the inverse cosine of your R, which is the adjacent side, over the hypotenuse, which is the apparent. Okay, so this will be your power factor. And for further understanding, this can be explained into a layman's explanation, like if you are drinking a beer. Okay, so in this glass, you have a glass of beer here. Okay, this is a glass. Okay, and there is a beer here, okay, up to this point, and you know that there are bubbles, okay, from this point there were bubbles here, okay. So it has been said that the measurement of this beer, okay, for instance, this is a beer, okay, the measurement of this beer from this point to this point, this will be our apparent, okay, apparent, and the bubbles here, okay, from this point of the liquid, the bubbles here are your reactive power, and the one that when you drink this beer, the one that you are having it drink, no, in your body is this part, okay, and this is also the real power, or the R. So you can liken this three types of power to this layman's explanation. Okay, so I do hope you are learning a little from this simple explanation of the three types of power. Okay, so by the way, the three types of power is based on the impedance. So therefore, your impedance also can be written in a right triangle. Okay, and you have here the R, and here is your X, and this is your Z. Your Z, which is the impedance, is the hypotenuse, and also you have here your theta. So therefore, we can write also our power, three types of power, into a right triangle because it is based on this representation where you represent your impedance into a right triangle. So okay, so always remember that in the alternating current in your AC, you have three types of power: the apparent power, the real power, and the reactive power. So this is all. Thank you so much for watching this video. I hope you learned something from this presentation. Thank you so much. You can share this video to your friends and like and subscribe. Thank you so much.